Okay, so we are going to use both the Pythagorean theorem and the distance formula to find the distance between those points. So to start with, we will put -3, -2 on the grid. And we'll put 4, 1 on the grid. And it's important to recognize that if we were going to use the Pythagorean theorem, that we could use the right triangle that I've created in blue there, or we could use the right triangle that I've created in red here. Either one of these triangles would be useful in finding the length of the hypotenuse there, but we're going to go ahead and use the blue one. So what we need to do is label A, B, and C. I'll call the short side A, the medium side B, and the long side C. We're going to replace the a squared plus b squared equals c squared with those values, giving us 3 squared plus 7 squared equals c squared. 3 squared is 9, 7 squared is 42, c squared. 9 and 42 makes 41, 49. 9 and 49 makes 58, c squared. We'll take the square root of both sides here. And we can just leave our answer like that. It's totally okay to leave your answer as a square root, like we see it there. Or we could actually take the square root of 58, and we get 7.62. All right, going over to the distance formula. It's important for us to recognize that there is an alternative to the distance formula that we see there, and it is this. And the difference between them is that if I was to square root the blue one, I would end up with the black one. And if I was to square the black one, I would end up with the blue one. And so it's just the inverse operation. We can manipulate this equation to make it look like either of those, the black one and the blue one, are really the exact same thing, just organized a little bit differently. And so what we need to do is remember that ordered pairs each have an x value and a y value. But if I was to say, hey, which one is the x? And here you might say -3, or you might say 4, because we have no way of identifying which x we're talking about. And so these sub numbers here, called a subscript, 1 and 2, tell me that if I say x1, I'm talking about -3, and if I say x2, I'm talking about 4. Those 1s and 2s do not operate like an exponent. They don't do anything. All that they do is help us name the point in a unique way. And so going down, we're going to put those numbers in the distance formula, but it's super important for us to do this and put a template together first before we start putting numbers in, because that minus sign in the middle could be problematic, and we're going to see why. So x2 is 4, x1 is -3. So see how I have two negatives there? Oftentimes myself, if I forget to put the template together, I accidentally just write 4 minus 3 there instead of 4 minus -3. So it's super important to put the negative in the template before you get going. And similarly here, we have y2 is 1, y1 is -2. Again, with the double negative, I might have made a mistake and just put 1 minus 2 if I hadn't already had the template put together there. So now d squared is equal to 4 minus -3 is the same as 4 plus 3, which is going to be 7 squared, plus 1 minus -2 is going to be 3 squared. And now you'll see that what we have for the distance formula is almost identical to what we had for the Pythagorean theorem. And so it is going to be really the same thing, just kind of organized a little bit differently. And now we're going to have d squared is equal to 7 times 7 is 49, plus 3 times 3 is 9. So d squared is equal to 58. We will do the square root of both sides, and we get d is equal to the square root of 58, which we already know from the Pythagorean theorem. is 7.62.